Hello, Math 120, and this is Professor Gonzalez, and I would like to do some problems from homework section 9.6. Now, 9.6 is taking a look at problems of systems of equations, of systems of non-linear equations. So that means one of the equations in the system would be non-linear. Now, when you take a look at number one, this first one is a line. So this first one is linear. This first one makes a line. This second one, however, makes a parabola. So what's going on here is, there's some different possibilities of how many answers you could get, right? Technically, you could have a parabola that's way up here and a line that's way down there, and so that would be a no solution. That's possible. It's also possible that you have a parabola and maybe this line that just hits it in one point. That's possible. So that would be one solution. It is also very possible for us to have a parabola and a line that goes through 2 points. But when you have a line and a parabola, two solutions. A line and a parabola, the most you can have is two solutions, right? Because the line's not going to bend around and hit it again. So we can see we can have no solution, one solution, and two solutions. So that's the kind of thing we're doing here. And I think I'm going to go down and just take a look at some of the other conic sections that we know about. We also know, that we have, let's see, a situation where you could have a parabola and an ellipse, right? Remember we have an ellipse. So in that case, you're going to have four solutions, right? So we have different possibilities here, right? You have a parabola and a circle, maybe something like that. I don't need to write every possibility, do I? So we've got a circle and an ellipse, right? So 4 points of intersection, so 4 solutions. Remember, the points of intersection are the points that work for both equations. So that's why, that's what we're looking for. We're looking for the points of intersection. Now, there is a caution here. And I think what I'm going to do is I'm going to take a look at kind of like that first problem that we did, not the same exact, but how about a parabola and a line? So if I look at a basic parabola is just crossing at, starting at 0, 0 is the vertex. And if I go to the right, up 1, right. So if I go right 2 and square it, I get out 4. 1, 2, 3, 4. So that point right there is called 2, 4. So I'm gonna write that down. That's just a basic parabola, y equals x squared. And if I make a line that goes with that, so this is gonna look something like this. Okay, of course you have its symmetrical partner over there. But if I have a line that goes through, let's make it go through 0, 0. Like that. So that would be y equals, and it looks like we go up 4 over 2, so that's just 2. Y equals 2x, right? The slope on that is up 1, 2 over 1, up 1, 2 over 1. So there's that equation, right? So here's the caution that I want to give you. We're trying to solve for the solution. And you can see here that there's actually two solutions that work. 0, 0 is going to make the first equation true. It's going to make the second equation true. And 2, 4, when I put in 2 for x, 2 squared is 4. It works for that one. If I put in a 2 for x here, 2 times 2 is 4. That works for that one. So both of these equations work. Both of the solutions work for both equations. And you visually can see there's 2 points of intersection. But here's where the problem can happen. Let's say that you are trying to solve the solutions here, and let's say that you end up getting y equals 4 so far, right? So let's say you did some work and you have, so you're doing your work and you get y equals 4. Okay, if you put y equals 4 into the linear equation, into the line, so let's look at the line. I'll do that in red. The line was y equals 2 times x. And if you put actually 4 in for y and solved, you would divide both sides by 2 and you'd get x equals 2. Well, it works, yes. You'd get a 2 right there. So that would be the solution. But what would happen if you decided instead to put that, let's move that down. What if you decided instead to put that into the our second equation, or no, our first equation, which our number one equation, which was the parabola. So once again, let's say you didn't know the solution for x and you knew y. So you're working for this, you got y equals 4. You say, oh, I'm going to put it into my parabola. The parabola says y equals x squared. So then you go ahead and substitute this 4 in for y. And how do you solve for x? You square root both sides, and when you square root both sides, you have to say plus or minus. And when you say plus or minus, we get a plus or minus 2. So we're in fact going to get this point, negative 2 comma 4, and we're going to get 2 comma 4. Well, you can see that negative 2 comma 4 is definitely wrong and should not be there. And so that's going to be an extraneous solution. So really, I mean, if you have the option to work with, when you're subbing back in, you have the option to work with a line or a parabola, you're going to want to put it into the line because you're not going to run into the problem with the line. But sometimes you have conic sections that have these square terms in it, circles, right? At least one of the variables for a parabola. The ellipse also has square terms in them, and this causes this situation, right? So whenever you have to square root and you get a plus or minus situation, you really need to double check that. I mean, if you visually know what's going on, you could kind of figure that out visually, but a lot of times you guys aren't probably not going to be fast enough to graph in your head what's happening. So what you do whenever you get a plus or minus situation from square rooting, you really need to check for extraneous solutions. And here's an example of that situation. All right, let's go ahead and do these problems. I hear my dog barking in the background, and my kids are supposed to take care of that, but of course they probably won't. And I've got this thing going. I can't stop because whenever I have to stop and have to edit, it always takes forever to post. Okay, well, let's go ahead and do this problem. So it's saying solve by substitution. Well, this is basically saying, right, we're looking at this, it says y equals this stuff. And on the second equation, it says y equals this stuff, right? So couldn't we say y, that those two are equal to each other? If they're both equal to y, well, then they must be both equal to each other. So really, you can set them equal to each other, right? So you've got, when you do that, you've got x squared plus 9, and that equals the other equation, x plus 9. So we go ahead and solve, and this is a quadratic, so what we're going to do is we're going to subtract x on both sides. So we've got x squared minus x plus 9 equals 9. Of course, we subtract 9 on both sides, and we end up getting x squared minus x equals 0. We can factor this, factor out an x, so we get x minus 1 equals 0. Set each factor equal to 0. Set each factor equal to 0, solve. And we get x equals 0, or we get x equals 1. So now what we want to do is, I wish I would have used my space a little better, but what we want to do now is we want to plug x equals 0 back into one of the equations. You get to pick, and plug x equals 1 back into one of the equations. And I'd recommend picking the line, because you're not going to have that issue of square rooting and getting a plus or minus and then having to check for extraneous solutions. So we're just, and the line's easier to work with anyways, right? So let's go ahead and use the line equation. That's y equals my x value plus 9. What is the x value in this case? Well, the x value in this case is 0. So therefore, y equals 9. Okay, I think we've got our ordered pair here. We've got 0, 9. There's one solution, 0, 9. And let's get the other solution. Now the other solution is just going to use this value over here. So it's going to be y equals, I'm using that same line equation right here. Right, so we've got y equals x plus 9. So we're just going to put 1 in for that equation. And that gives us y equals 10. Okay, I think we've got our second solution, which is 1, 10. And there are the two solutions for this equation. You could always sub them back in to double check and make sure that those two ordered pairs work for both the parabola and the line. Let's do another one. It says find all real solutions for the system of equations using the substitution method. So we're going to use substitution again. They're asking us to. And so here's the system. And we see that y equals x squared minus 2. So we're going to plug y equals x squared minus 2, and we're going to put it in for y. Now be really careful here because, right, we've got x squared plus, now we got y has to be squared. And what is y? Well, y is x squared minus 2. So then we copy the rest of that equation. It says equals 4. So now we have to be careful because we know that this is a perfect square binomial. You FOIL it out or whatever you want to call it, right? You multiply it out. And when you do that, you get x squared minus 4x plus 4 equals 4. Not x squared, I'm sorry. Let's see, this is already x squared. So this is x to the 4th. So we get x to the 4th. Let me show my work with that one really quick, just so we're on the same page. So basically I'm taking x squared minus 2 quantity squared. That means x squared minus 2 times x minus 2. So when you go through the whole process of saying x squared times x squared, you end up getting x to the 4th, and x squared times negative 2 is negative 2x squared, and negative 2 times x squared is negative 2x squared, and negative 2 times negative 2 is 4. So then, when we combine like terms, so we get the x to the 4th minus 2x squared plus 4. And that's what I have here, x to the 4th minus, I'm sorry, let's see, minus 2, this is minus 4. Right, I don't know how I wrote down the wrong thing, but a negative 2x squared minus 2x squared is minus 4x squared. So there's your minus 4x squared right there. And we have plus 4. So that just came from the multiplication process. And my gosh, I'm really miscopying things, or maybe I'm hitting the backward button and erasing it. I don't know what's going on, but that's supposed to be x squared. So that, you can see where that came from. I used the color to really highlight that, hopefully. And now we just want to collect like terms, right? And also at the same time, why don't we also say subtract 4 on both sides, which just zeroes that out. Also, we're also going to see that we have some like terms. Like this is 1x squared, and we've got a negative 4x squared. So when we collect our like terms, we're going to have x to the 4th. A negative 4 plus 1 is negative 3x squared. The constants go away. And so now how do we solve that? Well, we do it by factoring. And I do see a common x squared that I'm going to factor out. That's going to leave me with x squared minus 3 equals 0. Okay, so now what do I do? Well, I set this factor equal to 0. And you square root both sides. You're not going to have a plus or minus 0. It's just 0. So there's one of my x values. And this x value, right, it's going to be x squared minus 3 equals 0. So that's going to be x squared, add 3 to both sides. So x squared equals 3. And then I'm just going to, let me zoom in. I'm going to square root both sides. When I square root, I have to say plus or minus. So don't forget that. That's going to give us x equals plus or minus square root of 3, because square root of 3 does not simplify. So we're going to have, looks like 3 possible answers. Now we did square root both sides, and so that is probably in general, we need to remember that if we're square rooting both sides, we really probably need to check that. So we'll go ahead and check that in the end. But we do need to pick an equation to work with. So looks like equation number 2, you can pick either one, but equation number 2 looks simpler to work with, right? It's already solved for y. So why don't we just do that? So we're going to take equation number 2. I'll do that in red. And that just says y equals x squared minus 2. And what is x? Well, x is 0. So 0 squared is still 0, so y equals a negative 2. So that gives me my first answer, 0 comma negative 2. So my first answer is 0 comma negative. Whoops, and lost my pen. There it is. Okay, so my next answer that I need to check out is, well, what if, and so you see the plus or minus, let's go like this. There's the positive one, and let's write this one, there's the negative. Just so we know we've got to actually solve for both, and you're going to see something happen. But anyways, let's go ahead and pick that same exact equation, y equals x quantity x squared minus 2. We're going to do that for both of these. But you can see that positive square root of 3 goes here. And when you square a square root, you get the radicand 3. And 3 minus 2 is 1. Right? So we end up getting the square root of 3 comma 1. Now you're going to see pretty fast that the fact that this is a negative root 3, the thing is you're squaring, and so you're saying negative root 3 times negative root 3. Well, that becomes a positive because you're squaring a negative. That makes it a negative times a negative. So this is just going to be 3 minus 2. You're going to get the same exact y value. The x value, remember, was different, so it does produce a different answer. So this one's negative square root of 3 comma 1. So it looks like we have 3 solutions, okay? What we can do here, especially since we had this situation right here that I was talking about, plus or minus square root of 3, it's a good idea to check those. And it's, you know, if you have time, it's a really good idea to check all solutions, but especially when you're square rooting both sides of an equation and inserting the plus or minus. That can, in some situations, can cause extraneous solutions. And like I said, down here, it caused an extraneous solution in some situations. Some situations it doesn't, and some does. And I can just tell you, I don't know if this will land with you, but the reason why it happened is because when you put in a value of y equals 4 right here, when you put in a y equals 4 into that system, if you put it into the line, it's definitely going to land right on the answer right there. But if you put that y equals 4 into, I'm not sure if that was the right color to use because it's kind of hard to see, but if you put a y equals 4 into the parabola, right, it's going to tell me all x values that work with that. And so when you put in a y equals 4 into the parabola, it's going to give me an answer here at negative 2 and a here at positive 2. But remember, we only wanted positive 2. So that was an example that gave us an extraneous situation, extraneous solution. And you can see that happened when we got this plus or minus from square rooting both sides of the equation. So not always does that create extraneous, but it can. So unless you're really, really good at this stuff, you know, it's probably just a good idea whenever you get square rooting both sides and get a plus or minus, it's probably a good idea just to check it. So how can we check these two that look suspicious, I guess? The square root of 3 comma 1, we're going to check that with equation 1. Now, what was equation 1? Equation 1 we had over there, which was x squared plus y squared equals 4. So just x squared plus y squared equals 4. Okay, well, we're going to put in square root of 3 for x, and we're going to put in a 1 for y. And the square root of 3 squared is 3. 1 squared is 1, and 3 plus 1 is 4. Check. That worked. Now the thing is, you don't really, if you're, you're aware of something, you don't really have to do the next one, because if you think about this, the next particular problem, it has just negative root 3, right? And so what if this was a negative? What if we were checking the negative square root of 3? Well, negative square root of 3 squared, still, because a negative times negative gives you a positive 3, and you're still going to have the same results. So it turns out that root 3 comma 1 and negative root 3 comma 1 both work. And we're not as suspicious about this, but you can check that one as well. More suspicious of the plus or minus situation. Okay, let's move on to the next problem, number 3. Solve the system by elimination. Oh, yes, this should be kind of nice. Elimination means you add the two equations up, and hopefully an x or y eliminates. Well, if I add the two equations, I get 1 x squared plus 1x squared is 2x squared. And x and y squared and negative y squared, well, that zeroes out, leaving us with 5 plus 13 is 18. I divide by 2 on both sides, and I get x squared equals 9. Now I square root both sides, and I get a plus or minus. This gives me x equals plus or minus 3. All right, well, what should I do? Well, I should take x equals negative 3 and figure out what the y value would be, and x equals positive 3 and figure out what that y value is going to be. Now remember, we can use either equation number 1 or equation number 2. They both have squares in them on x's and y's, so really no advantage. Might as well take the equation that has a plus. Maybe that's a little bit easier. So I'm going to take equation number 1, and I'm going to, well, let's see. Yeah, we're trying to find the y value. So equation number 1. So equation number 1 says x squared plus y squared equals 5. Okay, so let's see what happens here. Now we're going to put in a negative 3. Right, we got our negative 3 right there. Put that in. Negative 3 squared is positive 9 plus y squared equals 5. If I subtract 9 on both sides, I'm going to get y squared equals negative 4. Now remember, when I square root both sides of this problem, I'm going to get an imaginary solution, and we are looking for real solutions. And in fact, the last problem said find all real solutions. I wish they stayed consistent and said that here. But remember, these are real solutions that we're talking about, that we can graph and see. And so we're only talking about the real solutions. So anyhow, when you get a non-real solution, you're going to say the answer is no solution. Now, we probably need to check the other one because that was with our first outcome with using a negative 3. But I think you're going to see when you take the first equation again, and it says x squared plus y squared equals 5. If you put in a positive 3, that positive 3 is still going to give us 9 plus y squared equals 5. And when you subtract 9 on both sides, you get a negative 4, which is still going to give us this imaginary solution. So no solution there either. Okay, moving on to the next problem. It says solve the following system of nonlinear equations using the method of elimination. So the method of elimination means that you have to, when you add them together, something must eliminate. So what we must do here is we need to modify, I think equation 1 is fine. I'm just going to copy that down. That's just x squared plus y squared equals 12y. But what I want is when I add them together, something eliminates. So I need opposites. So I'm going to multiply both sides of this equation by negative 1. Well, when I do that, I get a negative y squared and I get a negative x squared, and I get a negative 5y. So now I'm going to rewrite that over here as negative x squared equals negative 5y. And now when I add the two equations, I get that to zero out. I'm left with y squared equals 12 minus 5 is 7y. And I am left with a new equation with just y's in it. So that's perfect because now I can actually solve for y. Whoops. What's going on here? I don't want to do that. I don't know what came over me there. I can see that this is a y squared and it's not a perfect square, so I'm going to subtract 7y on both sides. This gives me y squared minus 7y equals 0. I'm going to factor out the y, and I get y minus 7 equals 0. So I set each factor equal to 0. I get y equals 0. I set this factor equal to 0, and I get y equals 7. Now what do I need to do? I need to plug it back into one of the equations to figure out what the ordered pair is. So I think I'm going to take equation number 2, which is this one right here. So if I take equation number 2, it says, I'm going to take it as its original form, which was x squared equals 5y. So I'm going to take x squared equals 5 times y. Now what was y here? Y is 0. So this gives me x squared equals 0. So x equals 0. So now we got a solution over here, which was 0, 0. And over here, let's see what happens when we take that same equation, x squared equals 5y. Oops, let me try that again. X squared equals 5 times y. And what's our y value here? Our y value is 7. So then we get x squared equals 5 times 7 is 35. We square root both sides. And now we are definitely going to get a plus or minus. X equals plus or minus the square root of 35, which doesn't simplify. And now, what are we going to do? Well, now I think we better check this one. So let's go ahead and check at least where we got the plus or minus case. Remember, I got an answer here, 0. And if you check 0, you can see that pretty quick. If you put in a 0 here, and so you put a 0 here and square it, and 0 there and square it, you're going to get 0. And if you put in a 0 right here, multiplied by 12, you get 0. So that is 0 equals 0. Same thing is going to happen with equation number 2. It's really these two other answers that we're a little bit worried about. So because you have a plus or minus, what we're really worried about is this one working, square root of 35 comma, and what was its y value? It was 7. I'd like to check this, by the way, check. And then the other one was negative square root of 35 comma 7. Okay, so I'm trying to remember what this, it was a while when I did this. I think I put it in there's one of them that I put in MyLab, and it was actually giving me an error. MyLab was wrong. And once again, if MyLab has an error and you have it right, you need to email me and I can override the grading process on that. But let's finish this out here. So I'm running a check here. So what does that mean? That means both equations have to work. So let's do the first one. Equation number 1. Equation number 1 says, it says x squared plus y squared equals 12 times y. Okay, well, x is the square root of 35, and y equals 7, and y equals 7. Okay, let's see what happens. Squaring the square root of 35 gives us 35. And we also know that 7 squared is 49. So 35 plus 49, that gives me 84. And 12 times 7 is 84. So I am very confident that that answer is correct. And now that works with equation number 1. It also must work with equation number 2. So let's do that. If we go over here and look at equation number 2 is this guy right here. So x squared equals 5y. X squared equals 5 times y. So once again, x is the square root of 35 and y is 7. Well, when I square the square root of 35, I get 35, and 5 times 7 is also 35. So check. This square root of 35 comma 7 works for both equations. Now we really don't need to run this check again because the only difference is that negative symbol. And you can see, had we put a negative here, it would have, because you're squaring it, it would become a positive and we get the same true result. And had we put a negative into this one, that would get squared, which would become a positive, which also would give us a true result. So we don't really need to run that again. So we can go ahead and say with certainty that my solutions are going to be those two and included with that. So we got 3 solutions. Okay, let's take a look at number 5. Solve the system by any method you wish. All right, what do I wish to do? I think I wish to solve by substitution. Okay, so I'm going to do this by substitution. And let's see if I could highlight this. Y equals this mess. And I'm going to replace this mess in for y right there. So what does my new equation look like? It looks like this. 7x plus y, this big mess, equals 34. What was that big mess that y equals? X squared minus 8x plus 4. Now let's go ahead and clean this up a little bit. I've got x squared. I'm going to combine some like terms like what? 7x. Negative 8x is going to be negative x. I also have a negative, I should set this equal to 0. So I'm going to subtract 34 on both sides, which gives me x squared minus x minus 30 equals 0. Now I need to factor this. What number is this? Number 5. I need to factor this. What multiplies to negative 30 and adds to negative 1? That's just going to be x minus 6 times x plus 5. So now I set each factor equal to 0, so I get x equals 6. Set the second factor equal to 0, x equals negative 5. And then what I have to do is I have to plug back into either equation and solve. And remember, when you're dealing with equations with squared terms, you might get that plus or minus case, which you have to do more checking. So I would like to take this equation right here, which is just a line, meaning x is to the first power, y is to the first power. I don't have to worry so much about that. So I'm going to take equation number 2 to get my y value. So equation number 2 just says 7 times x plus y equals 34. Well, it turns out that we got what for x? We got x equals 6, so I'm going to put a 6 in for x. 7 times 6 is 42. Plus y equals 34. I subtract 42 on both sides, and y equals a negative 8. So I got an answer 6 comma negative 8. Let's go ahead and figure out what happens here. I'm going to take that same second equation, number 2. You could take number 1, but remember, once again, if you get plus or minus, then you need to check for extraneous solutions. I'm going to take that same equation. 7 times x plus y equals 34. Now, what was x in this case? A negative 5. So 7 times negative 5 gives me a negative 35 plus y equals 34. Well, I'm going to add 35 to both sides of the equation, which is just going to give me y equals, what's that going to be? 71. Um, 60, what am I doing? That's 69. Whoops. I can't even read my own writing. That's a 5. There we go. So that's going to be 69. So the solution is, the first one is right here, 6 comma negative 8. Then we got negative 5 comma 69. All right, moving right along to number 6. Number 6 says solve by any method that you wish. And this thing, man, if you're not going to go with elimination, you're trying to make the problem harder. Because look at that. Positive y squared, negative y squared, they're going to eliminate. That's going to eliminate right off the bat. It's ready to go. 1x squared plus 1x squared is going to give me 2x squared. And 81 plus 81, well, that's going to give me a 162. Okay, so we know that's 0. I don't need to show that right there. I'm going to have to divide by 2, which gets me back to 81. How convenient. Then I square root both sides, and we don't forget our plus or minus. We're gonna end up with x equals plus or minus 9. So let's just show those two by kind of breaking it out. We got x equals positive 9 or x equals negative 9. Let's go ahead and get our y values that go with that. Now notice both of these equations, equation 1 and equation 2, both have square terms on them. So, we're gonna have some plus or minus issues happening here. In fact, we already did right here, so we're going to need to do some checking on this problem to make sure that we're not going to get extraneous solutions. But I'm just going to take equation number 1. Really, they're both not the best because they both have square terms, but equation 1 says x squared plus y squared equals 81. So what we're going to do is we're going to replace x with 9. Well, 9 squared is 81. And when you subtract 81 from both sides, well, that sure got nice real quick. Y squared equals 0, so y equals 0. So there wasn't a plus or minus in the end on that one. So we end up getting 9 comma 0 because you can't have a plus or minus 0. Let's take a look over here. And, we're going to have a similar thing happening. We should get the same answer, right? Because when you square a negative 9, it makes it positive 81. And then the rest is the same as the problem we just did. We subtract 81 from both sides. We get y squared equals 0, so y equals 0. So in this case, it was negative 9 comma 0. Okay, we did have a plus or minus at the beginning, so that just in general probably should double check that. So let's go ahead and run a check on this. So what do I need to check? I need to check, I'm checking, and remember, because one is positive, one is negative, if we're squaring it, we may only need to check one of these answers. Let's start with 9 comma 0, and let's also start with equation number 1. Now equation number 1 is just x squared plus y squared equals 81. X squared plus y squared equals 81. Well, let's see. X is 9 and y is 0. 9 squared is 81. 0 squared is 0. When you add that together, you get 81 equals 81. So that works. What about our equation number 2? Because remember, it has to work for both equations. Equation number 2 just says x squared minus y squared equals 81. Once again, our values would be 9 and 0 for y. 9 squared is 81 minus 0. Well, that's still 81, which makes that true. So I know for sure that 9 comma 0 works. Now, without having to do a whole bunch more work, I should be able to figure this, if it works or not. And I can do that quickly by realizing the only difference is a negative here. And if I square that negative, I still get a positive, which means it works. And if I put a negative here, I still get a positive, which means this works. So both of my solutions work. So I do not have any extraneous solutions here. The answer is just going to be 9 comma 0 and negative 9 comma 0. Let's take a look at number 7, and this is the last last problem that we have. Number 9 actually, or number 8 actually had some issues in my lab, so I just canceled that. You'll notice that on the homework on one of them I was able to, it just said the instructor removed a problem, and the other one I just was able to cancel it completely. So let's do number 7, and then we'll be done. I just want to make sure that I meant to go back and erase this so just no confusion. But this number 8 is not a problem. So I'm just going to do this so you guys don't look at it and think we got to do it. There, it's gone. And it's also gone in my lab. So let's take a look at this. So solve the system of nonlinear equations using any method. So what method did I want to use? I'm trying to remember, what did I do? I mean, there's different things you can do. Well, I think I just wanted to use substitution. Yeah, I think that's what I'm going to do. So I'm going to go ahead and take this equation right here and solve for y. So I'm going to subtract x on both sides. This gives me negative y equals negative x minus 5. I multiply both sides by negative and I get y equals x plus 5. Okay, so now what I'm going to do is I'm going to take that and I'm going to substitute it in for y right here. Let's see what this new equation looks like. So notice I started with equation 2. I solved for y and I subbed it back in equation 1. I used both equations. Okay, so now I'm going to take this guy right here and I'm going to write my new equation with the sub. This gives me quantity x minus 6 squared plus, and then remember this is the y value that I subbed in. It's now x plus 5, and that equals 85. Okay, well, I think we're going to have to do some multiplying here, of course. We have to multiply that out. And when I do that, I get x squared minus 12x plus 36. And then when I multiply this out, I get x squared plus 10x plus 25. And on the right-hand side, I got 85. Let's start combining some like terms. Like I see an x squared and an x squared. Well, that makes 2x squared. And I also see negative 12x and a positive 10x, which makes a minus 2x. And I also see 36. What do I see here? 36 plus 25, which should give me 61. This is a quadratic, so I definitely want to solve, set it equal to 0, and factor. So I'm going to set it equal to 0 by subtracting 85 off of both sides. I get 2x squared minus 2x, and this is going to give me a minus 24. Ooh, this is turning out to be easier by the second because I see a common 2 that I'm going to factor out. I now have x squared minus x minus 12. And I believe that's going to factor pretty quickly. What multiplies to negative 12 and adds to negative 1? X minus 4 times x plus 3. Negative 4 times 3 is negative 12. And negative 4 plus 3 is negative 1. So I set each factor equal to 0. Now this factor doesn't make sense setting equal to 0 because that's not true. But any factor with a variable in it sets equal to 0. X minus 4 equals 0, so x equals 4. X plus 3 equals 0, so x equals negative 3. I've got 2 answers for x. Now I need to use either equation 1 or 2 to get its y partner. And equation 2, as we can see here, is going to be a whole lot easier to work with. There's no square terms with it. So that's what I'm going to use equation number 2. Equation number 2 says x minus y equals a negative 5. Well, the x value is 4. So now I've got 4 minus y equals negative 5. I'm going to subtract 4 off of both sides. I get negative y equals negative 9. Therefore, y equals 9, if I can make a 9. So it looks like I've got 4 comma 9 as a solution. Let's take a look at this guy over here and use the same equation number 2, which is x minus y equals negative 5. Of course, on this particular problem, we know that x equals negative 3. We plug it in. I'm going to add 3 to both sides of the equation. And this gives me negative y equals negative 2. Multiply both sides by negative and y equals 2. I get negative 3 comma 2 as my second point or second solution. So 4 comma 9 and negative 3 comma 2 are my two solutions. And that is it. I hope you're having a great day, and I hope this helped. You take care, and we'll talk to you soon. Bye.